use as we're studying processes. Our goal is to get you to 3. It says, I understand the concepts of processes as it relates to operating systems, software, and services, and can apply the concepts of processes to understand how operating systems work, how software services work and relate to each other. I can use various tools to troubleshoot or analyze the effects of processes on the operating system. So take a look at the different scales. 3 is the one we're going after. I want to get you to this point where you understand at the level 3. Now that we've reviewed the scale, let's take a look at our learning goal. Let's make sure we're always keeping that learning goal ahead of us. Understanding processes, the student will understand the concept of processes as it relates to the operating system, software, and services. Our goal is the student will be able to apply the concepts of processes to understand how the operating systems work, how software services work and relate to each other. And then last of all, the ultimate goal is the student will be able to use various tools to troubleshoot or analyze the effect of processes on the operating system. All right, so I want to start by let's going back and understanding the CPU. So I'm going to draw my CPU, and I'm not an artist. So this is my CPU. One of the things we have to really understand in the world of computing is that CPUs really, for all their power and all their complexity, and they are all of that, is that they execute one thing at a time. So your typical single core CPU executes one thing at a time. Because it executes it, let's say this is a 3.1 gigahertz processor, because it's executing different threads of processes, very quickly it gives the illusion that things are all running at the same time. That is not true. They are only running one at a time. Only one thing at a time can be executed by the CPU. That will help us as we understand multitasking operating systems. So let's first take a look at, I've got a number of processes running. And I'm going to draw the processes, and we know that processes can have one thread, they can have 60 threads, depending on the software developer. So I've got a number of processes here waiting to access CPU time. What determines who accesses what and when is what's called the scheduler. So let's just draw this right here. And the scheduler makes the determination as to who has access to the CPU and what priority. This is very, very important because the scheduler looks at all the processes that need access to CPU time and decides based on algorithms. In fact, so when the scheduler says, okay, you're in, this thread will run through, or this process will run through, will be executed, and it will access RAM, hard drive, etc., whatever it needs to do. It's very interesting. This is what we call multitasking. This is what we call a multitasking operating system. Whenever you have a scheduler that is controlling the processes and which one has access to the CPU next, this is called multitasking. When you come down here and you give the operating system control of the scheduler, so let's give the OS, now it controls the scheduler. This is called preemptive multitasking. We're going to give the operating system control of who gets when and what. If I move my mouse, if I have a mouse and I move it, I wiggle it on my desk, there may be a process that is handling the driver for the mouse, and it needs to move that cursor on the screen. So the operating system will decide, okay, this process needs to be executed next. So anytime the operating system controls the scheduler as to what process goes, that is called preemptive multitasking. There is a operating system called cooperative multitasking, but we won't go into that. Most Linux, Mac, Windows operating systems work on a preemptive multitasking type idea. CPUs began to increase in clock speed. One of the problems that was facing Intel and AMD was heat. So we were getting more and more heat coming off our CPU, and it was more difficult to cool them as our clock speeds went from 2 gigahertz to 3 gigahertz. This was becoming more and more difficult to cool down these CPUs. But Intel and AMD both wanted to improve the performance of their CPUs. So they began to do something called HyperThreading. What they did was they added approximately, according to Intel, about 5% more circuitry to their CPU design. And what happened was they were able to now execute 2 threads at the same time. So they could bring 2 threads through the CPU and actually execute those almost simultaneously in one CPU. This was a great improvement because we weren't adding a lot to the circuitry, meaning we would rise the cost of the CPU. We were keeping our clock rates down to manageable clock rates, and we were still getting better performance as we allowed multiple threads to go through our CPU. Then we began to actually add multiple cores. This was even better. So in one CPU die, they actually had 2 CPUs complete. This allowed us to now have the potential power of executing multiple threads at the same time at significant speeds and still have one die. As Intel and AMD began to look at even adding hyperthreading into the dual core, we could now entertain 4 threads simultaneously. Again, keeping our clock speeds at manageable clock speeds. Now we were being able to do much more throughput. A lot more code was being executed by hyperthreading multiple core CPUs, and that was giving us the illusion or the appearance or the effect of a faster and faster process. More processes and threads could be executed with the same speed, and it was relatively inexpensive. So as we learn and look at the operating system, what is the software that's on my PC that really makes up what we call processes? So let's talk a little bit about that, and let's go find where this software is that's making up most of the processes that we're going to look at, troubleshoot, and work with. Number 1, they're user installed. This is the software you install. You take your CD, you download from the internet, you load on your PC. The other one is services, and we'll look at services carefully because this is going to be primarily services are primarily software modules that are installed by default when you install Windows. Many applications that you install also add services, and we'll look at those. Then finally, there's components of the operating system. When we talk about processes, we're really not talking about the kernel, the operating system kernel. We're really talking about user-installed software, services, and various components of the operating system. So here we are on that location of your hard drive where you install software. And notice the location is going to be in your C drive under Program Files. This is a 64-bit operating system, and so under Program Files in this category, because it's 64-bit, all of these applications that I've installed, they're all here. These are all 64-bit applications. And every time I launch Java, iTunes, my iPod software, Internet Explorer, these are all going to launch a process. You can also see I have Program Files x86. That's how I know this operating system is 64-bit, because it has the existence of Program Files x86. So everything in this folder are going to be software packages that I've downloaded, taken a CD-ROM, installed from the internet, and these are all 32-bit applications running in the 64-bit operating system. Anytime I launch these are going to launch processes. It's important to realize that when I look at, let's say I'm looking at Internet Explorer that's installed, it's a 64-bit browser. You can see as I mouse over this folder, it shows me it's 20.6 megabytes worth of files. But only one file, or maybe only a few of these files, ever launch a process. For example, Explorer.exe is an application and it actually launches the process. And yet there are hundreds of files in addition in this folder that are used to support or they run inside the process. And many of these will be running threads inside the process. So even though I have many files in Internet Explorer folder, only one or two are actually going to create, launch, and set up a process. There may be hundreds of files required to run the process and run various threads that are needed in that process. Be sure you start learning what are the files that actually launch processes. Those are of great interest to you as a tech. I'm now in the x86 program x86 folder, and I'm looking at TechSmith, and you can see as I mouse over 148 megabytes of files are in that folder. But when I open it up and I look at Cam Studio version 8, there are only a few of these files that actually launch processes. Most of the DLLs and other files that are in this folder are used to support the processes that these files launch. So again, what is the software on our PC that really plays the role in processes? A lot of it is our end-user software found in program files, and if you're a 64-bit operating system, program files x86. So this is a major player in the role of processes on our machine. Another area is services. So I'm going to go to my C drive. I'm going to go to this PC, and notice my computer is gone with Windows 8.1. So I'm going to go to Manage, and I'm going to open up Computer Management Console. I'm going to expose the Computer Management Console, and I went ahead and went down to the snap-in called Services. These are services. These are software modules that are installed primarily by Windows, although you can see some. Here I've got an Adobe Acrobat Update service. You can see some applications also install their software as services. Services are different than user installed software in that the operating system controls when they start and stop. With user-defined applications, the kind that you install, you go to their icon, you launch their shortcut, and you run the program when you want it, and you terminate Word when you're done with it. Services are run by the operating system, and you can see we've got status. We can see that not all of the services that are installed on this PC are running. I can see some are running, and I can actually right mouse click, and I can stop, I can restart, I can change the properties. Primarily, this software is very important to us. Most of it is installed by Windows, by Microsoft, when you install the operating system. But there are many of the services that are running that are also installed by software that you install. So why are services so important? Because they make a major portion of the processes that impact our disk, our memory, our hard drive, and our network. So these are often areas of troubleshooting. We must understand that services are major components of software, either installed by Windows or installed by applications we have installed. When we run Process Explorer and we go into the color section, and I'll show you, we'll go over here to Options, we'll go to Configure Colors. One thing that Mark Rusunovich has done as he wrote Process Explorer is he's used a color system that really helps us identify these categories of processes. He's done in pink, he's done services. So when you come over here and you see a list of processes that have a pink color, those are services. Those are modules of software that are running under services. He also has done the blue. It's called Own Processes. These are processes that you have launched upon your logon. As you slide this down, let me end this up. I'm going to come down here, and you can see all the blue colored processes were processes or modules of software that were launched upon my logon. When I logged on, this software was either manually launched by me or was automatically launched because of configurations that I chose. So the blue are all modules or processes that are launched under my credentials when I logged on. And you can see that even goes back up into here. I see some different modules of processes. I see some processes here that were started upon my logon. So I see a number of processes up here that were all begun or launched or created when I logged on. Back to Mark's coloring of processes to help us identify what is what. The blue is going to be processes that we have launched under our credentials. When we logged on, these processes were launched. Services should be in pink. Now there is some that are just, he has went ahead and gave some colors. Green are processes that are being launched or started. Red are processes that are being terminated, those states of those processes. Down here we can see that when I suspend a process, you notice that we have the gray color. And so we see a couple of those processes in that color. We have relocated DLLs, and we'll talk about those later. .NET processes are yellow also. Immersive processes, we'll give a little bit of discussion about those. And then packed images. These are ones you want to watch out for. If you have a purple process, you want to pay attention to it because it might be malware. This coloring is very customizable, so you can adjust it to your heart's desire. There's a couple of processes that require some additional attention. One is the system idle process. If the scheduler does not have any process to run, then a very special process will run through the scheduler and execute on the CPU. It's a very special process that is generally just used when nothing else is in the scheduler to run through the CPU. It contains one or more kernel threads, and its purpose is to keep the scheduler always with something to run. The system idle process will always give up its space in the scheduler if any other process needs to run. Another important process, which really is not a process according to Mark Russinovich, is the interrupt. The interrupt is really an indication of hardware interrupts and DPCs. If you have high CPU utilization under the process called interrupts, generally that's an indication of a bad driver, maybe a buggy driver. You might want to take a look at your latest install or maybe some recent hardware installations. When we're using Task Manager to look at processes, we click on the Process tab. We don't have the benefit of colorized processes, so Task Manager is a wonderful tool and gives us a great deal of information about our processes. It is not as helpful as Process Explorer. Resource Monitor is another one of my favorite tools when I'm analyzing problems in the operating system because it too is very helpful in allowing me to look at processes. It misses some of those nice features that we do enjoy with Process Explorer. Another wonderful feature of Process Explorer is it actually shows us the child-parent relationship between one process and another. Let's take, for example, services.exe. This is a process that is critical to the operating system, and it really sets up the paradigm for all services to be launched. So you can see that this is the parent process of every pink process or process that is a service below it. The relationship helps us to understand that parent-child relationship that's going to be very crucial when we troubleshoot. Process Explorer also gives us the mouse over. Notice I have an svc host.exe, and when I do the mouse over that particular service or that process, I can see each service that is launched under that svc host.exe. This is a great feature and allows me to understand what services were launched under that. I can come down here and again mouse over that particular process and see exactly those processes that are being launched under that particular svc host.exe. To give you an idea of how we use this for troubleshooting, we had recently a service, and let's say it was this one, and we saw that this particular process was running 20% utilization on the CPU, and it was really impacting the user's computer. We could see that from the mouse over, we could see each and every service that was being launched under that svc host.exe. So we then went to the services. And one by one stopped each service that was in that list until we found the service that all of a sudden, when we killed that particular service, CPU utilization went away. By eliminating the service that was causing the problem, we were able to then go into Event Viewer and troubleshoot that problem and find out the exact problem that was causing that CPU utilization. By being able to observe the child-parent relationship, many times it gives us an insight to how the developer writes the program. Here's Evernote, one of my favorite cloud services, and I can see that it launches two simultaneous sub-processes below it. These are child processes to the Evernote parent. That gives us some indication that for whatever reason, the developer has decided to launch 3 additional processes that probably give features and functionality to the Evernote program. In analyzing processes, we're always going to be looking at how processes impact 4 hardware systems. We call these the 4 hardware subsystems. We're going to look at how processes impact CPU. How do processes impact our memory? And that's going to be both physical and virtual. We're also going to look at how the process impacts our disk. And last of all, how does it impact our network? Those are the 4 major hardware subsystems we are always going to be looking at in troubleshooting and analyzing processes. For quick troubleshooting, Resource Monitor does a marvelous job of allowing me to select any, let's say for example, the cam recorder. I've selected that process, and it filters the disk activity, the network activity. I can scroll down and see the memory activity. This is really nice because it allows me to quickly analyze how that particular process that I selected is impacting those hardware subsystems. I can also come over to the graphs, and I can see in the graphical display again that same issue. How is that particular process impacting those hardware subsystems? When I use Task Manager and I go to the Performance tab, I can see the overall condition of those hardware subsystems. I can see how all the processes and the kernel is impacting CPU, memory, disk, my Wi-Fi, my Ethernet. It's just a great dashboard that looks at the overall health of my hardware subsystems. In Resource Monitor, I have a little bit better view of how processes are impacting these hardware subsystems. I have an overview, which gives me a quick look, and I can see read and write and total read and write input, output on my disk, and I can see what process is doing the most reading and writing. I can look at the network. I can even see IP addresses. This is extremely important when I'm hunting malware. I can look at various processes and their impact on memory. So this is a great tool that allows us to look at processes, again, the overall health of our PC as it runs processes against those 4 major hardware subsystems. When I click on CPU over here, I can drill down even further. I'm going to use the cam recorder. I'm going to select that particular process, and now I can look and see, is there any services running related to this process? And we see there is none. I can look at handles. Handles are things like registry keys, files, folders, graphical elements, and we can see there's quite a few of those being used by that particular process. And then under associated modules, I can see all the DLLs that are being called up into the memory and being used by this particular process. When I choose the memory tab, I can look at how the camrecorder.exe process 8024 is impacting my various elements of memory. When I click on disk, I can also see, I can pull this down and I can see how the process and its various threads are writing and reading the disk. And it gives me a great insight to how this particular process is impacting my disk subsystem. And when I choose network, again, I'm looking at the camrecorder.exe process. You can see that there really is nothing that particular process is doing on the network. There's no TCP connections. There's no real network activity, and it makes sense because that particular process normally wouldn't access the network. Process Explorer, much like the other tools, is going to do a great job. When I mouse over, this gives me my overall CPU usage. And notice that I can actually hover over any area and it shows me the particular process that's using the most CPU. Very handy. Here is the memory usage. Here's my physical memory. This is virtual memory. This is physical memory. This is I/O, which includes disk. And this is my GPU. I can also click this little icon here called System Information. And I can again get that good overview of how my system on a whole is being impacted by all the processes running. This is a very nice feature, and you can see I can mouse over and I can look at any one area and it will tell me what process is responsible, say, for this spike up here. So I can see various processes are responsible for the spikes and elements that I'm watching real time. Process Explorer allows me even more information. If I right mouse click and go to Properties, I can go to the Performance tab and I can look at how this process is impacting CPU, virtual memory, physical memory, the I/O, which is primarily disk, and it really gives me that great insight on that particular process, all 4 hardware subsystems. If I click on the TCP/IP tab, it shows me all my network connectivity. So again, I can see all 4 network subsystems, all 4 hardware subsystems when I use